Good afternoon, everybody. Thank you, Patrick, for the previous talk. It was very interesting. So I guess also thank you to Scroll. Thank you to those listed by Scroll in the tweet storm for helping organize. This day is fantastic. Definitely very, very difficult to do with the long range, so few people originating not even just from this part of the world, but just, Bogota specifically. Today we're going to be doing a little panel with quite an eclectic mix on the takes of people who work in and around the Rollup space for a variety of different use cases. And I think people who have envisioned the problem and the solution very, very differently. So it's going to be interesting to see what goes on. As a small introduction, we have Oskar, who is the co-founder of Empiric Network, who's building the data layer for L2s and zero-knowledge rollups. As a Stark enthusiast, he's commenced that deployment on Cairo, but perhaps one day we'll see it moving to some others. Next in we have Remco, who I, not until today, had the pleasure of meeting, but I do love your technical Twitter takes. The 2Pi is quite the blog. He's held a variety of roles, investment, research, and notably and very recently was at OX Park as a research fellow, and now is the head of blockchain at Worldcoin. Next is Brandon, who's the CTO of Manta Network, but also now sort of permeating to Poxeidon Labs, where they're building a privacy-preserving, optimistic rollup. So a little bit different with a permeated account model, playing around with those UTXO to get that privacy inside of the sort of walled, scaled EVM areas. Also, fundamentally, I think a very enthusiastic type theorist. And last, and definitely not least, is Joe Andrews, who by academic training is an engineer and is now the head of product and co-founder of Aztec Network. So Aztec, I think, for many, many people, has been at the heart of solutions on top of, or around, or at core Ethereum itself. And the famous creators of Plonk, the proving system that it itself, or some modular part, likely and mostly the permutation, is used across an awful lot of solutions. Also the coiners, if I'm not mistaken, of the ZK rollup term. So those looking for privacy and scalability at the same time. So it'll be very refreshing to see the thought process that comes from that kind of angle. Okay, so the first questions, and allowing me to be quiet, something laying the groundwork and I guess paying some homage to the name of the day. Why rollups? Why do you feel that blockchains and distributed ledgers in their form today require this mechanism for scaling and staying true to some underlying base layer?
First of you, I wrote some notes, but I think, blockchains today are not really ready for kind of mass adoption. I think you can kind of see like one successful NFT mint or a project launch kind of grinds Ethereum kind of to a halt through really high gas fees. So we need a way to kind of scale that, and I think it comes down to everyone validating every transaction just doesn't scale. So rollups, specifically ZK rollups, let you kind of validate a proof of computation, which scales a lot better than validating all the transactions. So you don't have to trade off security for scalability if you use a rollup, is kind of my take.
And even if you have like lots of users, in a lot of cases that does bring the chain to a halt. Sometimes also there's applications that you can't even design on L1, assuming the gas fees that you're going to have to pay anyway. So it also expands the space of possible applications and rollups and the whole like L stack all the way up lets you sort of expand your design space and can bring many more developers into the area and to think about the kinds of apps that they can't even dream of writing right now on L1, for example.
Yeah, and specifically why rollups and not potential other solutions to the scaling problem. The base layer, we want very, very strong security guarantees on. That forces you into a corner that really limits your throughput. And on top of that, EVM and Ethereum has some design choices that they inherited that also prevent it from scaling very hard. So combined, for anything that requires real throughput, you need to have some solution. There's a number of trade-offs you can make there, but generally, if you want good forms of decentralization and trustlessness, and sort of an ability to hold the operator accountable, you need some form of data availability. And the only one that we currently know of that has like security guarantees that are on par with the base layer is to put the data itself on the base layer, hence rollups.
I have nothing to add.
Okay, and without that, yeah, to summarize, we've got some desire for just definitely generic scaling, and what I think is a well-justified statement to say that blockchains are awful. No, they're really far from where they need to be if they're going to be this new backbone of civilization that we're all talking about. We have a kind of nice fog of prescience where you could say, who knows what's going to happen? You know, now we can only sit and define and guesstimate all the different types of applications that we can have given these sets of parameters, these awful blockchains. So perhaps once we make them fast and safe, the things that will come, the host of that will be unknown and hopefully, I'm sure, very exciting if the builders can get a shift on. So in that, with these shared security, super scaling mechanisms, what are you most excited about? What behaviors, what applications, what even potential new styles of chains do you think that is going to be brought about? Not just in the way we perceive blockchain today, arguably a closed fence or a little bit of a walled paradigm, but really the next stage to cornerly quote whatever 1 billion users or Web3 to the masses, but things that perhaps people aren't quite envisioning.
Start at that end.
Yeah, I think one of the things that we are most excited about is, as we've already pointed out, there are things that change on rollups beyond just cost and speed. And a big thing that we're really passionate about is cheap computation that you can now do inside of your smart contracts. Our protocol, our whole project is based on that premise. And I can speak a little bit to that. For an oracle, for someone who's bringing data on chain, having computation, cheap computation available is really a game changer, because now you can start really going into things that we call computational feeds, which are very different to just the normal price feeds that we see on the L1 or elsewhere. Now, if we just zoom out and think about what does that mean, we believe, because we have these abilities now, and because we can build these novel data products now, that will enable other people to build much smarter DeFi protocols. And I think you'll see that across, not just DeFi, you'll see it in gaming, you'll see it in many different areas where these new things that you can do, and computation is one of them, privacy is another, and so on, they will really change what we can offer to the world. And I think that's what we're really excited about. Not to speak about the L3s and sort of app-specific environments. I think that will all be very, very interesting. Yeah. Curious to hear your thoughts.
Yeah, I can chime in with how we use L2 and Rollup technology at Worldcoin right now. So our goal is to bring 1 billion people into the Web3 world, and we want to target people with, let's say, wallets that hold maybe $10 worth, and still give them an experience that is meaningful for them, which doesn't work on Ethereum layer 1 with the gas fees involved there. And in fact, I would argue it doesn't even quite work with the layer 2s that are out there right now, which is why I'm pushing really hard for 4844 to get in, so we can get good performance there too. We have been experimenting with our own L2, one that is transfer specific. It's a optimistic rollup that uses BLS signature aggregation, which basically gets you the best of both worlds. Your call data is very compressed because call data is actually mostly transaction signatures, and now you only have one for a whole batch. And you have no verification cost because it's optimistic. So with that, we got transactions down to under 400 gas. Some tricks we can do to get it even further. That's exciting. Unfortunately, these really transfer-specific chains are not as valuable to the users, because that's what, like, the peer-to-peer transfer use case makes sense if you have a very, very broad adoption. Like, to bootstrap something, you really need the wider Web3 ecosystem with you, and like let people interact with all the protocols they know and love, like the Uniswaps and the compounds and the NFTs and you name it. That forced the L2 space into EVM compatible chains, because that allowed all these projects to just quickly deploy and reach out to the user base in a now much cheaper environment. It'll be interesting to see how that evolves and if we're really going to cling to the EVM as tightly as we do there. But there's a second use case of L2s that I also want to highlight. Like, one of the things we use is Semaphore, which is a protocol to create like anonymous sets on chain. We use this for our privacy protecting proof of personhood. Right now, to insert an identity, you call a function in a smart contract that adds your public key to a Merkle tree, and it costs 1 million gas. The reason it needs to be done on-chain is to allow for concurrency, multiple people to create a transaction at the same time going in a random order. What we do to scale this better is we have a sequencer that just aligns a couple of these insertions up in a batch and then creates a zero-knowledge proof that updates the Merkle tree in one go. This is basically a very primitive, minimal rollup already. Like, we create blocks, and we zero-knowledge proof these blocks and publish them on-chain with just the minimal amount of information people need, basically just the leaf values to recover the tree if they needed to. And this is like the area where we get into the app-specific chains. Like, this is about as simple as it gets, but you can see this evolving. Like, we can also do something on the claim end where we aggregate batches of claims and allow people to do more complex queries cheaply on-chain about their identity. So yeah, I'm excited about where the L2 space, where whole ecosystems grow and come together and interact with each other work, plus like these use cases like we have where we just want scaling for a particular thing. And I guess a third use case for L2s would be when there is value in having different kind of block aggregation mechanisms. You could, for example, think of batch auctions, batch auction markets, where you want to aggregate a whole bunch of transactions and settle them all at once. That has a number of advantages other than that you can find optimal, find more better optima than you would be able to create with sequential transactions. But you also need this if you want to do things like have perfect privacy in complex transactions.
Yeah, I think that's yeah, you made a lot of great points. One thing certainly that you touched on that I liked was that Merkle tree, like minimal L3 sort of. And I think that there's sort of two different independent ways you can go about building rollup type scaling solutions. You can have this kind of thing where you build this sort of, you figure out what batching scheme you need for your protocol, and then you build an L3 or however, whatever layer you're on to scale that piece. One thing that the kind of stuff that I'm working on and my team is working on is trying to not go in that direction, but go in the direction of enabling applications themselves to run with ZK as part of their code. So think like ZK apps, right? So the idea is that for an application where you want to do scaling, you just take let's say you write some Solidity code, you pass it through, you deploy it on L2 instead of L1. It's now just cheaper over across the board. Instead, if we look at the most expensive parts of what makes ZK applications, what's the most expensive part of them is stuff like the really intense cryptography needed for, let's say, verifying proofs on chain or doing some sort of batch signatures, pairing algorithms, all this kind of stuff. And so, what if you built a rollup that was specifically optimized for those kind of computations, right? Then you could have people building ZK apps on top of this rollup, where it's not an app-specific rollup, it's sort of a ZK-specific rollup. So so any application that uses ZK technology in it would get a speed boost in this special rollup, right? And then you can build these sort of L3s on top, where let's say you're doing something like private transfer, you want to do like millions of transactions at once. You use the L2 to speed up any given verification, then use an L3 to do batch verification for something like that, right? So these are sort of independent directions you can go in when developing rollups, and the kind of things that we're focused on is basically giving developers access to ZK in their applications, rather than just figuring out a scaling solution that's specific for their app, right?
I'd agree with all of that. I think that the most exciting things are kind of thinking about applications that require private state, because that's not possible on most of the L1s we have today. So things like consumer finance, ZK games, they all require a developer to think and have these like ZK tools. So if you can build a layer which verifies those ZK proofs, I think you get to a really interesting endpoint where kind of applications become private. And that's kind of one of the things which is going to spearhead adoption in our view at Aztec. It's not just scaling. Like, we're kind of in a bear market right now. Gas costs are kind of nothing, and people aren't using Ethereum. So it's kind of the feature set of the rollups, and privacy is one of those features that we believe quite strongly developers need for adoption.
I think some really excellent answers, and also really excellent to, I think, see the takes that were more feature-based and more fundamental to looking at different permutations, iterations of the technology, rather than, which of course would have been fine and as exciting. Oh, we're scaled now we can do Visa. Or we're scaled now, and now we can do. That was very interesting, from things that are bringing about certain elements of privacy. I'm sure, I know from the way Aztec constructs its stack, they forecast a lot of requirements and necessity for privacy in a configurable way, which I think is super interesting, and seeing how that aligns well with scaling as it goes forward to open up new avenues for people to do other, standardly, you could say in the real world or the previous iteration, the Web 2, whatever we all exist in now, and seeing that happen with scalability is very interesting. I think joint between Brandon and Remco, I really liked, talking about different ways to find very, very low gas costs in the same way we have, whether something specific, without necessarily being app specific or ZK, or Remco's open problem, I think, was from example 2 of doing optimistic, but with BLS signatures, presumably to stop playing that exhausting gas Tetris you must do when a G2 is like, a G2 BN254 is like 2 million gas, and the G1's like 15 gas. You're like, we've got to sort of part and parcel all these. I do wonder if you can still keep things like that zero knowledge by running a different aggregation scheme, like a 2-round Schnorr, and then throw in a KCG10 to mitigate the call data. I think something like that, maybe it's a, but not for 400 gas, sort of around the 50. That's crazy numbers, I think, at this stage, but I like it. And first, but was, as a last, sorry, but was first, Oskar, speaking about what you can do with sort of app-specific and new applications to create L3s, which I guess takes us to our next and very important question as we attempt to have even greater prescience, because it's as the funnel opens up into all of the things we're going to do, predicting and the behaviors and the necessities forward such that we can design them in the correct way now is tiresome, I would say, one word. So computational constraint. And now we're talking about L2s here with general purpose compute. We talk about L3s with sort of app-specific L3s. So general purpose compute about taking this next layer above an L1, or you could also technically do the same with an L3 and keep going up. But do you feel that we need app-specific, whether L3, app-specific layers to run some back-end for gaming engines, some extremely high through point of sales? And how do you think those are going to fall into the existing Rollup narrative today? And do you think it is possible? I won't give my opinion. I'm not sure as a moderator I should be. Keep the bias to a minimum. That we're just going to be able to do away with these and just keep scaling some levels of compute and eventually have 1 billion transactions per second.
I think the L3 kind of conversation is a strange one for me personally, just because I think it's more an admission of the L2 that their execution environment is missing features. So I think that at some point there will be an L2 that has the features. Like, I'm very biased. I think that's Aztec, but I think you should be able to have apps that can run on your L2 that don't need to do kind of even more aggregation. Otherwise, you've kind of maybe missed the kind of specification of your L2 VM. Like, you may have focused too much on EVM equivalents as an example versus kind of privacy or some other features. So I'm confident that as technology increases, like, you'll have kind of apps that do kind of run on an L2, but they shouldn't need to do too much more like aggregation to get the scale that's required of that L2. And maybe, yeah, if the execution environment has programmability, those apps can pretty much do everything on the L2 that they need to, and calling them an L3 may be just confusing.
I think one other thing is that when you have an L2, and I mean, of course, this is way too early, but when you build L3s on top of the L2, you have, again, like everything else, you have sort of this ecosystem lock, right? Especially with this, with the partitioning of all of the value that's in the blockchain, you know, you're spreading it out amongst all these L2s, then, oh, even worse, you have to spread them all around all these L3s, right? So you have sort of this like ecosystem problem where if you're building an L2 that's going to do something specific, that's not just going to be, you know, EVM compatible across the board, you sort of have to have the right ecosystem for it. And I think something that would be really interesting to see is something like gaming companies, where a gaming company, let's say like, what's the, I forget what it is, Unreal, right? Like let's think like the Unreal Engine, right? Where the company that runs Unreal Engine would build an L2, and then games that run on Unreal would be L3s on this L2. And maybe you have, let's say, some game where you're playing a round of the game, and once the round is over, you know, you don't care about that state anymore, right? So these L3s, you sort of spawn them freely. You run your game on the L3, then you just commit the final state to L2, and you just forget about the L3 again, right? So you sort of want to be able to spawn up, you want to be able to spawn up random amounts of like high intensity compute and then pull it back, depending on the sort of demand needed for that application, for example. So whereas L2s can sort of give you this like all around scaling, you know, in certain instances where you have very high demand, or you need you have this like ecosystem lock where you might want to build L3s for that purpose, right? And because L2s because you have all these mechanisms like ZKP to be able to build L2s that can have arbitrary compute, right? They don't have to run EVM. They can be anything. So that sort of, I think, leaves the space a little more open. And like you said, right, like Aztec's focus on privacy. And so maybe you're making different choices in your VM that are more privacy biased. And in certain other instances, that might not be the right thing. And so I see L3s more as the place where L2s build their ecosystem, rather than some extra level of sharding. We have to just deal with more sharding, right? So I think it's more about an ecosystem in that case. Yeah.
Yeah, I really like the game example. I would say that like currently we have these EVM compatible L2s that they are inherently limited in the amount of scale that you can provide, because EVM itself is inherently limited. Like if EVM could do more, we could also do more on the base layer. The reason we get away with it in the L2s is because we compromise on a couple of things. Mostly about we mostly compromise on the consensus decentralization, which is kind of fine because by nature of L2s, it's mostly censorship. You're not too worried about consistency things there, because that is guaranteed by the base layer. But still, we have the EVM there, so so we are going to hit a scaling limit with the L2s. 4844 is going to solve the data availability cost of it, which will give us probably another 10 or 100x more room before we hit that limit. But we will definitely hit that limit with the various L2s out there way before every single in-game transaction is on-chain. So that necessitates L3s and the existence of like alternative solutions. Now the L3s, for the very same reason, if they are all rollups, they will not get any more scaling than the L2s get, because you still need to accumulate this data at the same place. So what you do there is you compromise even more on the security guarantees, which you can probably get away with, because in an L3 you're working in a very specific application-specific context. So you can provide, you have usually some level of trust, like in games especially, you would trust the server that you're currently gaming on. So then you can probably move away from data availability and not be technically a rollup, but just be an L3 of a different kind. And again, the thing I mentioned earlier, where you want to experiment with new mechanics, new ways of new transition rules for your block that are not easily implementable in EVM, things that aggregate over many transactions, things that implement very game-specific logic, for example, that you need an experimentation space for that. Probably want something that can verify something complex cheaply, so an L3 there would also be a very natural answer.
Yeah, I think I mean, it's interesting because we're obviously implemented on Cairo right now, so not EVM compatible or equivalent. So it's a bit different, but still there, we talk about L3s all the time, and the thing that I think we're excited about there in that ecosystem is that you can do things like, privacy is not something that StarkNet sort of gives you built in, but you can have that with an L3. If you want something, if you want to build like a really performant order book, right? That's something that you might want to do on an L3. If you have like a very specific NFT protocol that you'd want to build, maybe an L3 is a better solution for that. For us, certainly, if we want to, currently what we're doing is we do kind of simpler things. We do, we construct a yield curve that we compute on chain. We construct sort of market volatility oracles on chain, right? Those are relatively straightforward computations. You can imagine that we could like do very, very, very complex things that you couldn't do on the L2, and I think that's what we're excited about. And there's a bunch of great teams like Slush and so on thinking about this kind of stuff on StarkNet and elsewhere. And so we're sort of we have an interesting, a different view to you guys because we're sort of trying to build on that, right? And so we're really excited about all the different possibilities that we do see for all the different L2s. Yeah.
Yeah, I think I'd just kind of maybe count. Well, I guess like I think there's a trade-off between the kind of lock-in requirements that you were saying, like as you go further down this like layer stack, to just building a kind of more specific L2 that kind of doesn't have those trade-offs, because you're basically kind of trading off the ability for a user to get out of the system to somewhere else for kind of being on a particular L2, which has got an incorrect feature set for your actual application that you're trying to build. So I lean more towards seeing, I guess, app-specific rollups. But I think that's, like, in that I can see, like, Starkware's value proposition is, like, immense throughput, and they've sacrificed EVM compatibility for that, and I think that's a fair trade-off to make, because it enables a lot of public applications that maybe don't need kind of some of the things you have on Aztec.
I think that's what's really exciting about this whole space is that, people are willing to experiment with all these completely different trade-off spaces, and people aren't just like focused on one thing. So I think it's really exciting either way.
Excellent answers. Do not have time to summarize. We can hasten to the last question, and Toggle doesn't start throwing things at us, pacing around the room. I just want to quickly talk. It's been touched on, I think, very, very nicely about, and I shall keep this to us. We touched on very nicely on privacy, and this feels like the old flame in the ZK rollup. From whatever it was in the 60s, from Goldwasser et al., creating these computations or this kind of concealed computation as part of an arithmetic circuit, to seeing blockchains have a kind of serious use case. When I first had the fortune of jumping on the zero-knowledge cryptography train a few years ago, it was witness encryption, and it was private encryption. Yeah, I'm coming. It was private encryption for attesting to some certificates in browsers, back with bulletproofs. And since then, it turns out that little arithmeticization, that little witness-preserving computation of some program is a hell of a lot smaller and a hell of a lot cheaper to verify on chain than you would, or we don't necessarily have the necessity to do so we don't have mega servers anymore. So to those, and I guess the two panelists on the left, very, very relevant to their need and desire for privacy in the Web3 ecosystem as we go forwards. Do you see that there's any clash between providing privacy and scalability? Not necessarily just for now, because I think it's more arguably yes. Encoding and encoding is doubly expensive. You're doing Merkle trees and Merkle trees, like mobile phones, the way you guys do, or the extended UTXO with the old spending model. But for like sort of the very much long term, do you see that you have to make a trade-off for the two of these, or for any or is it that privacy-preserving applications or privacy-preserving behaviors work better and work or tessellate even into well-scaled platforms? That would be difficult. And then the last quick sub-question there, because we talk about this a lot, and it's not brought up enough on Twitter and whatever other outlets, that do you think some of the designs and some of the protocols creating and envisioning the rollups for today, just ZK rollups, so the Validium style non-private, will have issues retroactively adding privacy.
I think you'll find that the answer to both is the same. It is you need to get rid of global mutable state that allows scaling, that allows privacy.
I think it's very hard to retrofit privacy as a sub-question. You kind of always need a UTXO model, and having kind of an account-based model makes privacy very hard. You need privacy to be by default, else you just have privacy being used by people who have something to hide, which is kind of not the norm. I think that the start of the question, in terms of scalability, I think we can like compete with Visa and MasterCard costs with the current design space in terms of like transactional costs. I think the elephant in the room for ZK privacy like rollups is client-side syncing. Like the current model is download and then try and decrypt every single transaction, which doesn't scale. So that's like the big elephant in the room, which I think there's not enough people talking about.
Yeah, I think just to end it here, because I think Toggle is getting nervous. So, yeah, I think there's definitely some trade-offs in the near term, but I think in the long term, as you see, one trend I think that we're going to start seeing is that optimistic rollups will be able to, whatever customization they're allowed to make in their VMs, you'll be able to find a ZK replacement for it. And so the sort of design we're trying to get to try to get privacy in there faster is do an optimistic rollup that has privacy as a feature app developers can use. And then as ZK technology starts getting better on the scaling side, not on the privacy side, we'll be able to transition into ZK rollup. And so, maybe this is the opposite direction of what Aztec does, but I think we're starting as an optimistic ZK and then going into ZK in the future. And I think it's going to be very clear that you can replace all optimistic systems with ZK. Maybe it takes 10 years, but maybe it takes 20, but definitely going to happen. I don't see any reason why it wouldn't happen. Yeah. Well.
I guess we're at an end. Yeah. How serendipitous that ZK privacy brought us ZK scalability. Thank you, everybody, for listening, and to the panelists for taking your time, and once again, everybody organizing. It's an absolute pleasure.